But there really are two different types of rational equations to solve. The first one can be used or can be done using cross multiplication. As you can see here, you have one fraction equaling another fraction. And when you have one fraction equaling another fraction, you simply just do cross multiplication to solve. So this times this and this times this. You do have to be careful though. When you do the 2 times the 2x minus 7, it does need to be multiplied to both of them. So it'd be 2 times 2x, which is 4x, 2 times negative 7, which is negative 14, equals going the other direction. But just like the other direction, you do need to multiply both of them. So x times 5 is 5x, and 8 times 5 is 40. Then you just simply solve. Okay, this is a linear equation. I don't have any squareds or x squareds or quadratic, so I'm just going to solve for x. It's just as simple as that. So I'm going to subtract the 4x over here, which gives me negative 14 equals 1x, or just x plus 40. And then I'll subtract the 40 over, and I'll get, move that down, x equals negative 54. So some of them can be just as simple as that. Other times you'll get a little bit more complicated equations. So when we look at, let's look at number 2. So I'm going to cross multiply here. So x times x is x squared equals x times negative 4 is negative 4x, and 1 times negative 4 is negative 4. So, unlike linear equations like the previous problem, in the previous problem you could just solve for x, but in this problem we have a quadratic. This x squared tells us that we have a quadratic, and in quadratics, if you remember from a couple units ago, you have to have everything on the same side of the equal sign. So I do have to move this over, I do have to move this over. So what I have is x squared plus 4x plus 4 equals 0. Now, just like with anything in terms of math, there are multiple ways to solve quadratic equations. You could put that into quadratic formula and get your two answers, or you could realize that this is factorable. What multiplies to be 4 and adds to be 4? Well, it's 2 and 2. So since they're both the same, my answer is just x equals negative 2. Because if you set it equal to 0, subtract the 2 over, you get x equals negative 2. And that's your answer. So if we were relating this to difficulty, number 1 would be an easy one. Number 2 would sort of be medium because you get a quadratic. 3 would be a little bit more challenging just because of the amount of work that's required. You're still going to get a quadratic in this case, but you'll see that it's not any more difficult. What makes this a little bit more difficult is I have to do all of these multiplying. So when I multiply this times this, I have to multiply both terms by both terms. So I have to do sort of like a FOIL here. So x times x is x squared. 1 times x is x. And then I have to do the others. X times negative 6 is negative 6x, and 1 times negative 6 is negative 6. And that's just one side. So when I combine this, I get x squared minus 5x minus 6 equals, now, get that out of the way and make it less confusing here. Now I'm going to go the other direction. X times x is x squared. X times 2 is 2x. Negative 3 times x is negative 3x. And negative 3 times 2 is negative 6. So now that I'm done multiplying everything, I can start combining like terms. So one of the things I'm going to do is move everything to the same side. So you'll notice that when I bring the x squared over, in this case, when I subtract the x squared and subtract the x squared, what happens? Well, they cancel. So what I'm left with is negative 5x minus 6 equals, now I'm going to combine these two, 2x and negative 3x is negative 1x minus 6. And I'm going to solve. Let's see, I'll add the 5x over. So I get negative 6 equals 4x minus 6. Add the 6 over. You'll see that those also cancel, leaving me with 0 equals 4x. So if I divide by 4, x equals 0. And so you can see that that problem's a little bit more work to it because of the sort of all the multiplying that you have to do.